All right, welcome back to Statistics. So today we're going to talk about test hypothesis with proportions. So there's a couple of things we got to go through first. There's some conditions on using this. One is that your sample size can be no more than 5% of the population. Okay. Your p hat, your n times p hat, and n times 1 minus p hat, this gives both sides of the value here, have got to be bigger than 10. Okay, so what that means is, like, if you have a very small proportion or a very large proportion, that even though there's always an infinite number of numbers between 2 points, this still has to have enough sort of like a zoom to be able to get a normal distribution no matter how close you've gotten. Okay, and that's what this is telling us. This is more for independence. Okay, if I'm going to ask, I have say 100 people in a supermarket, and I ask say 50 of them. Okay, do they think their wait time is going to be longer than 3 minutes or shorter than 3 minutes, or pick whatever number you want? There's going to be some correlation. There's going to be some relationship between all of the people that are there. Okay, they're all having a similar experience, so their independence is not going to be quite there. Okay, so that's, if I get 100 fraternity members, like from one fraternity, and ask them what their favorite fraternity is, or ask them anything. I can ask them what their favorite brand of milk is. Like, they all have a shared and similar experience, so I don't think they're going to be independent. Okay, so that's why we have those two things. Okay, I'm unlikely to ever ask you about this one, because I don't expect students to know enough about the world or situation to be able to say what's going on here. Right, so if I asked you, like, something you're unlikely to know about, I want to know, like, what if all the cherry trees in a particular orchard are over 114 inches in height? Okay, that's a throwback to the last section. Well, how many cherry trees are in the orchard? Is it, is it more? Did you only sample 5% of those and less, or did you sample more of those? Like, how are you supposed to know? So I don't like to ask you questions regarding this thing. Okay, I may ask you questions regarding this. Okay, so something to keep in your mind, that n times p or n times 1 minus p has got to be bigger than 10. Okay, and that's just to keep it far enough away from the boundaries so we don't bump into it and we have a proper normal distribution one way or the other. Okay, so here we go. We have a sample size of 57, and there's 45 individuals of interest. So we have n is 50. Actually, let me go ahead and regenerate this one. I'll say skip, so we can get a fresh problem here. Try another. Perfect. Okay. So in this case, we have 57 individuals. 36 of them provided an answer to a question. Okay, for 57, we have p is equal to 36. Okay, so we'll randomly select 6th graders and ask them whether or not they've tried tobacco. Make it out of the whole school district or whole state or whole, a larger idea, so that 57 is not 5% of the population. The population is much bigger. This is way less than 5%. Okay. Look for different schools, of course, to make sure everything is independent. Okay. So compute sample proportion p hat, answer at least 3 decimal places. So you'll usually have to go through this because I ask you the whole question as a whole thing rather than as bits and pieces. I mean, there might be bits and pieces, but you can read it all at one time, unlike in this situation. So 36 over 58, 3 decimal places. So we're going to do 36 over 58. Okay. And we get 0.621 for our thing here. So 0.6, just double checking, 621, 621. Okay, and that's our answer for that part of it. It depends on which calculator you're using. okay, if you're doing this by hand, but generally you won't have to concern yourself with doing that. As you enter all of the information into the calculator to do the last problem, it will answer the first couple of problems for you anyway. Are the hypothesis questions answered? So we want n times 0.621. Okay, this is 58 times 0.621, and then we want 58 times. We have to get the 1 minus this. Okay, so if something costs $62.10, you put your $100 bill down. What change are you supposed to get? Okay, I'd like to get $37.90 back. These add up to 1. Okay. Again, I'm not trying to belittle anybody talking to you about like how to do arithmetic this way, but I also know that some people are a little intimidated by doing fractions like this, and you shouldn't be. You can make change. That's all this is doing. Okay. So what's this going to equal? What's this going to equal? Okay. So what do we have here? We have 58 times 0.621. This is, yeah. Okay, and we get 36. Okay, and then we're going to have 58 times 0.3790. Okay, and we get 21, 22. Both of these numbers happen to be bigger, right? Both of these numbers happen to be bigger than 10. So we're set. Okay. All right. So yes, we have found the conditions. Okay. So what we're going to do, so yes, number of individuals in each category bigger than 10. So we are okay. Okay. So desired test, P is equal to 0.6. So HO, P is greater than 0.6. H1, P is greater than 0.6. Okay. Compute the Z statistics, round to 2 decimal places. So what we're going to do is we're going to go to statistics. So just stat. We're going to go over to tests. Okay. We're going to go down to where it says 1 proportion Z test. Okay. So later, chapter 11, we're going to be dealing with 2 proportions. This is 1 proportion. Okay. So we've got 0.6. That's our P. Oh no, what is it? Okay, portion, yeah. So what are they trying to compare to? They're trying to compare to 0.6. Okay, P hat will be the number we just calculated. Okay, and see how they have the X over N here. So we're just going to type it. They don't even want us to bother typing this stuff in. We're calculating this out on our own. They're going to do it for us. Okay, so P0, this is the given proportion that they want us to test against. They're going to ask us an X over N, and you might ask, like, what if they only gave me like 0.33? Well, then we say this is 33 over 100. So 33N over 100 for X, or sorry, 33X over 100 for N. Okay, so if they terminate the fraction, all we're going to do is write it as a fraction rather than as this thing. So we can go ahead and do that. And do they want greater than? They want a greater than. So this is a right side test, right? This is a right-tailed hypothesis test. So we're going to stick with the greater than, and we'll go ahead and calculate. Okay. So our test statistic, 0.3216. Okay, so it's 0.3216, 0.3216, 322. Okay. 3216. So that's going to be 322 rather. All right, and now we're going to do the critical values. Okay. Since it's a right-hand side, right, we use the whole alpha value here. Okay. And what we're going to do, and by the way, I will not be asking a question like this. So I feel like I can't remember how to do this. Like, no worries, you're not going to be called upon to ask it. So we want the inverse norm. Okay. And what we're going to do is we need a low value. Okay, let's go with -5. Okay, you can do 1E99, that's fine. But all the tables that we have for normal distribution fall off at 3 plus or minus 3 standard deviations. We don't consider things with more than 3 standard deviations or 5 standard deviations. Okay, so we're going to go up to inverse norm. Sorry, I was going normal distribution. Okay. So you're not the only ones that I forget. So alpha is 0.1, so we want the probability of 90% to get that side of it. Okay, we could also use 10% and then fold it over because that'll be the negative part. Okay, and a 0 and a 1 for our standard deviation, and that should give us the positive side of our critical value. Okay, 1.28. 1.28. Okay, so we look at our test statistic at 0.322. It's smaller than the rejection region. Anything bigger than 1.28 would have been in the rejection region. This is not bigger than 1.28, so we do not reject the null hypothesis. Going with the way we've done it before, and I don't know why they mix and match the homework to change subjects on us, but they did. We can go back to, back up here. That test, 1 proportion z test. I hope everything is still there. It looks like it is. Calculate, what's our p-value? Our p-value is 0.3738. 3739 with the rounding. Okay, so 0.3739. This is our p-value. Here's alpha. Alpha was 0.10. Bigger or smaller? It's bigger. So we're not talking about an unusual situation here. Okay, this is to get this result was about 37% chance of getting a result like this. That's not that extreme. Okay, so we're going to say since p-value is greater than alpha, do not, right? It wasn't an extremely rare event. Do not reject HL. Okay. So do we have enough level to reject? No, we do not. Okay. And then there we go. That's all they wanted us to do. Okay. Not a big fan of a problem like this. I think statistics, all your problems should come with a story like this one. Okay. And it makes it a little bit easier to see exactly what the heck they're trying to do here. Okay, so you're unlikely to face number 1. I like number 2. Okay, I like having a little story, little bedtime story when I'm doing my problems here. Okay, so I tend to test you on, do you have a story? Okay, so we have a researcher reported that 71.8% of all email sent in a recent month was spam. All right. A system manager at a large corporation believes that the percentage at his company may be 78%. So his workers are getting more spam than average. That's what he believes. He examines a random sample of 500 emails. That seems delightful. Received in an email server, and finds that 369 of those messages were spam. Okay. Can you conclude that the percentage of emails of spam is less than 78%? Okay, test at these 2 values. Okay, so as usual, okay, what we're going to do for our information here is we're going to set up our hypothesis. Okay, so percentage of emails is less than 78%. So we're going to say P, we'll use the calculator's lingo, P is equal to 0.78, because that's what they're asking us to compare against, or P sub 0 is less than 0.78. Okay. Now we have, in part 2 here, we have an A that alpha is equal to 0.10, and we have a B that alpha is equal to 0.01. Okay. So here we're saying the alpha is 10%. Here the alpha is 1%. So we have a penny versus a dime. Okay, in our, what are we going to take? And this will be a good question. Because again, I'd like to point out like how changing your standards will change the result. Okay, So let's write down the other stuff that we have. Okay, we have email server. We find that 369. So this is our step 3. We're on the calculating our test statistic here. Okay. So the first thing we're going to do is write down the stuff that we know. We're going to say that 369 out of 500 emails was spam. Okay. And now we're going to go ahead and calculate that. So our test statistic, and our p-value. So we'll go back into the calculator. We're going to go to stat. We're going to go to tests. We're going to go to 1 proportion z test. Enter. So in this case, our p sub 0, what are we testing against? 0.78. What information were we given? 369 divided by 500. Okay, n is 500. Okay, and they want to know, is it the same as, greater than, less than, or too hard to tell? Okay, and they want to know if this is less than 0.78. Okay, and we'll just go ahead and calculate. Okay, so what happens here? Our z, our test statistic value, right? It's always z. Proportions always get a z. Do not use a t-value and try to give it degrees of freedom. That's not how you do this. Okay, our test proportion was negative 2.27. Okay, negative 2.27, we'll say. Okay, we don't really care about that so much. So if you don't write it down, that's fine. My education said write that down, but you're not actually needing it. You're not working the problem this way. And our p-value 0.011, we'll say 0.0117 here, okay? So this is 0.0117. Okay, so in part A here, for part A from this thing, what's our p-value? What's our alpha, right? Our p-value 0.0117, 0.0117. It's kind of like a penny, and alpha was 0.10. P-value is less than alpha. So since it's an unusual event because it's falling below our standard to call it unusual. In their case, 10% is unusual. We are less than 10%. So since our p-value is less than alpha, okay, we say, oh, that's unusual. We say reject the null hypothesis, okay? And we're going to effectively take the HA or take the H1. We don't have any other explanation. We're just going to take the alternative. We're not really taking the alternative. We're just saying, well, this ain't true. Like, well, what else could it be? I'm like, oh, I'm leaving that up to you. I'm not saying anything. Just saying it's not this, okay? But in real parlance, when we talk to people, we're going to say that, you know, what was our H1? Our H1, your proportion is less than 78%. All right. Now, we're going to do our p-value for the next one, right? And alpha, part B, okay, 0.0117, this doesn't change. But our alpha, our standard as to what is unusual, that is now changed, okay? So 0.0117 is bigger, smaller, or too hard to tell than 0.01. This is a little bit bigger, isn't it? So p-value is greater than alpha. We said, well, the standard for unusual is 1%. You didn't quite get down to 1%. It's close, but it ain't 1%. Okay. So because our p-value did not make it down to that range, we said, do not reject HO. And you go to your computer guy manager, IT manager, and you say, you're right. Okay. It is 78%. The proportion is 78%. Now, again, that's how you're going to communicate this to another human being. If you have to write this into a journal, if you have to write this, you know, I don't have a problem with you writing something like this. Okay, it doesn't have to be that formal. But if you want to be formal about it, it's like, well, we can't say that it isn't 78%, so we're not going to. that's hedging a lot, isn't it? Yeah, it is. But we can't say that it isn't. So it's 78%. It might as well be. But I'm not saying that it is. I'm just saying I can't say it's anything other than that. Okay. So that's the logic you have to use when you're reporting your systems this way. Right? And I know it's delightful. So then we'll go to our values here and we'll put all the stuff up for it. Okay. But in the interest of time, I'm going to just move to the next part. Okay. Confidence in banks. A poll conducted in 2012 asked a random sample of 1,239 adults in the United States. Our population is 330 odd million, so much less than 5%. How much they had? Oh, pick 2012. Okay. Picked how much confidence they had in the banks and other financial institutions. Total of 158 said that they had a great deal of confidence. Most people did not, because that was the 2011, 2012 recession there. Everything was falling apart. Okay, and I know most of you are going to be way too young to have good memories of this, so that's all right. Okay. Economist claims that greater than 11% of the United States had a great deal of confidence. Can you claim, what do you think about this claim here? All right, let's write down some stuff. Okay, what is, right, HO, HA, H1 rather, okay. So what are we arguing over? We're arguing whether or not 11% have a great deal of confidence in the bank, or greater than 11%. So we're going to say that P naught equals 0.11, and this guy thinks, this gal, doesn't matter. Okay, both genders can be economists. So economist claims a greater. Okay, what is our, oh, they want both. They want 0.10 and 0.01. Okay, so part A, alpha equals 0.10, part B, alpha equals 0.01. Okay, I'm kind of glad that they're asking us to change, because you can see as setting your standards change, your conclusion may change. That's why you're not allowed to change it later. Okay, so we're going to do part 3 here. This was part 1. This was part 2. Part 3 is calculator test statistics. Okay. Now, what if they only, like in this case, they said we have 158 over 1,239 people. Okay, this was my X, this was my N. What if they just gave us a proportion? They just said 30%. So what you would do is you would type in 30 over 100, the 30 for X, the 100 for Y. If they give you actual numbers, use those. But if they don't do it, and they say like 15% or something, then go ahead and type in the fraction, the decimal equivalent of that fraction. So I don't know how to do that. That's fair. So we're going to type in 0.3. Okay. We're going to go to math. We're going to go to making a fraction. Okay. So we're going to hit make a fraction. So 0.3 to into fractional form, 3 over 10. Remember that n times p is greater than. So even though we could do that, I would still rather write down 30 over 100. I know it reduces, okay, but for the sake of this thing, I would rather make it a slightly larger number. Okay. So, but even 0.3, even 3 out of 10, it'll probably be okay. So let's see what we have. So we're going to plug in the calculator. We have stat test. Okay. Oops, sorry. Stat test, and then we're going to go down to one proportion z-test. Okay, proportions again, they're always z-tests. Okay, this was 0.11. All right, x. Okay, that's 158. 158. My n is 1,239. Okay. And he's saying the right side of the curve. We want more people, okay, are excited about the economy or confident in the economy. Okay, calculator. Okay, and here is our values. So we're going to cut down our critical value. That was 1.97. Okay, and our p-value, okay, this was 0.0243. Okay, this guy right here, 0.0243. I know there's a lot of p's going on with this, but bear with us, please. Okay, and the proportion that they gave us, okay, this whole thing is going to turn out to be about 13%. Okay. So there we go. In part A, right, our p-value is 0.0243. Our alpha was 0.10. Okay, in part B, p-value doesn't change, 0.0243, and alpha was 0.01. So in part A, right, we said unusual is 10%, and your result is about 2% likely. So 10% versus 2%. Oh, this is the cutoff for unusual. If it's less than this, it's unusual. Well, that's unusual. So we're going to say p-value is less than alpha. Therefore, we're going to reject the null hypothesis. Okay, reject HO, because this is an unusual event. It demands an alternative explanation. Okay. In part B, our p-value is greater than alpha. Okay, we said that to be unusual, you have to hit 1%. Our chances were about 2.4%. Okay, so since the cutoff is 1% here, and we ended up with 2.4%, we're going to say, that's not unusual. It does not demand an alternative explanation. That's like, it's low, sure, but it's not unusual. So we're going to say, do not reject HL. Okay, so you can see if you were writing an article for, Washington, well, not Washington Post, but I'm trying to think of one of the business ones. You might, you're not supposed to do this, but you might set up this to be very small and say, oh, see, people have a lot of confidence in the economy. Shouldn't be panicking. Yeah, as long as you pick this out before you do it. Okay, and again, you have reasons. Right? 0.01 is like, this is the chance of making a type 1 error. What's the consequences of a type 1 error? You want to make sure that you're answering those kinds of questions. Okay, there's also a beta statistic or beta probability that we have to deal with. Instead of just alpha, we have beta. Okay, so what's the other probability? So these are, when you're designing this experiment and setting up on these levels, there's other things you have to take into account. Okay, so in part A, we rejected the null hypothesis. Okay, so we're going to say, what is our, no, say we don't have evidence for more than 11%. Okay, we're just going to go with 11%. Okay, because that's the, oh no, we don't. We have reject the null hypothesis, which, see, I messed this up too. Reject the null hypothesis. So this is out, this is in. Okay, so we're going to say, we're going to say, oh, rejected. So erase. Do not reject the null hypothesis. No, we did reject the whole hypothesis. I'm sorry. Reject HL. So what's our alternative solution here? Alternative solution was probability is greater than 11%. The proportion of adults who have confidence in the economy is more than 11%. All right. In the other way, right? P-value is greater than alpha. So we do not reject the HL. What's HL? HL's proportion is only 11%. We have no evidence to say it's greater than. Okay, so the proportion is only 11%. Okay. And again, you'd say something more clever, like we have no evidence to suggest that it is greater than 11%, but we do have evidence to say that it is 11%. But again, we don't ever actually say anything. We just say what it isn't. Okay. So we'll go ahead and we'll go on to the next one just to give us some time rather than adding all this stuff up. But there we go. All right. Again, these are very similar types of problems. Okay, these are very similar. I'm inclined not to ask you that. It's like, I know that most of the people who take this class happen to be nursing people. It's not that nurses aren't interested in taxes too, but like I have a feeling that, you know, talking about smoking and HIV and nicotine patches is much more in your interest than financial stuff. Okay. So we're going to say we have a proportion of 444 HIV positive smokers. 202 reported that they had used a nicotine patch to try to quit. Can you conclude that less than half of the HIV positive smokers have used a nicotine patch? Okay, 0.01. Okay, so here we're going to go. Next problem. Okay, HO. Oh, not mu. We want P sub 0 here. Okay. Let's see here. All right. So we're going to say it's either half or it's less than half. Like they didn't say half. How do you know? Like they kind of implied it that we're testing against half. Okay. So we're going to say it's half or greater. Okay. So P 0.0 is equal to 0.5. Oh, remember P is always the equality. H1, we're saying that it is less than half. Okay. Less than half. Okay. Now, our alpha, thankfully, they stopped us asking to do 2 of these problems. They just asked us to do 1. So alpha equals 0.01. So alpha is equal to 0.01. Okay. Now for our test statistic. And again, if they didn't say anything about a test statistic, right, they just said out of 444 people, 0.5% of them, we would just take this and say divided by 2. Okay. But our X is equal to 202. Our N is equal to 444. 444. All right, and we're just going to go ahead and type that in. So stat test 1 proportion Z test 1 proportion. There is no 1 proportion T test. Okay, so you have to remember the proportions, they're all Z tests. Okay, so 1 proportion T test. How many people are in our X? We have, oh no, sorry. This is 0.5. Okay, our X is 202. Okay, our N, how many people in total? 444. Okay. In this case, we want the left hand of the side because we want less than half did it. And then calculate. Okay, so again, our Z statistic or test statistic, negative 1.90. Okay, so our test statistic, negative 1.90. Okay, and our p-value 0.0288. Okay, our p-value 0.0288. Okay, so what is our alpha? Our alpha is 0.01. Okay, so our p-value 0.0288, our alpha 0.01. You said this was the level that we would be able to see something, and we didn't get to that level. Right? It's 1 penny. We got to almost 3 pennies. Didn't quite make it. Okay, so what we're going to say is since p-value is greater than alpha, Okay, 0.0288 is greater than 0.01. So do not reject the null hypothesis. Okay, do not reject the null hypothesis. So we have no evidence to say that less than half did anything. We're just going to say that half of them did it. Okay, so we conclude. Okay, what's the null hypothesis say? Null hypothesis is 50%. Okay, we conclude 50% of HIV people, HIV smokers, tried to quit. With nicotine patch. Right. All right. Well, again, I'll let you guys type that into the computers and see what's going on there. Okay. But no, we can't conclude that that happened. Okay. So 50% or more did not, or tried to. All right. Next. Okay. Again, same problem as the other one. I want to keep this under forever minutes. So we'll pick a medical one. Okay. Vertical banded gastroplasty is a surgical procedure that reduces the volume of the stomach in order to produce weight loss. Okay. In a recent study, 82 patients with type 2 diabetes underwent this procedure. 59 of them experienced a recovery from diabetes. I don't know if you could say that. I mean, you can experience a relief of symptoms, but I don't think you can say I'm cured. Okay. Does the study provide convincing evidence that less than 72% of the people who undergo the surgery will recover from diabetes? Okay. By the way, if you know somebody who was considering this kind of surgery, the gastric bypass thing, please look at experiences who did not work. Okay, because this is not 100% successful. Like, check what the percentage of not successful is before you decide, or before you tell a loved one, like, hey, you should do this. Like, check. All right, so here, less than 72% will recover from diabetes. Okay, so we'll P sub 0 less than 72, and we'll say equals 0.72. Equality always belongs to the null hypothesis. Okay, so we're going to say less than 72%. That's what we're trying to prove. Alpha 0.05. Okay, 0.05. Our test statistic. Okay, what is our number that did this? What is the total number? Okay, so we have 82 patients with type 2 diabetes. 59 of them experienced remission of the diabetes. Okay, 59 rather. Yeah, 59. Okay, we're good. And then we're going to go ahead and do all the rest of this. So calculator time. We go to stat. Okay, so we're going to go hit stat, test. Okay, one sample proportion t-test. That's this one. So our P0 is 0.72. So 0.72. Okay, our X in this case, 59. Okay. Sample size, 82. See, we never, like that first question, we never did any of that ever again. Test. And I'm also not likely to ask you a question like that. Okay. At the beginning, like number one is not a good question. P0 is less than. So here we are with less than. Calculate. There we go. Okay, our Z was 0.0098. So our critical value . 0.0098. Okay, that's my z value. Negative for what it's worth. Okay. Our p hat, or our p value rather, is 0.7195. Okay, our p value 0.7195. So nearly 70% chance. No, p value is 0.4961. 0.4961. I'm sorry about that. 0.4961. Okay. So our p value, alpha. So we have 0.4961, alpha 0.05. Okay. Since this is our cutoff, okay, if it's more than this, we're going to say it's unusual. We need an alternative explanation. So since p-value 0.4916 is a greater number than 0.05, right? Almost 50 cents, 5 cents. Okay, we do not reject the null hypothesis. Okay, so what's the null hypothesis say? 72% of the people have this happen. Okay, so 0.72 proportion, right? 72% of diabetics who underwent this procedure show signs of remission of diabetes. Again, I'm not interested in saying cure like the book did, because I don't know if there is a cure for diabetes or not. You certainly can do things to not suffer from it, but yeah, again, we should all be so lucky. No, not everybody can do that. It's okay. All right, so HO, P is equal to 0.72, right? That's what we're given. Okay, and they wanted less than. So we want P less than 0.72. This is a left-tailed test. Right, 0 point. Okay. Compute the p-value for the decimal numbers. That was our p-value, 0.4961. All right. All right. So we do not reject the null hypothesis. Okay. And there is not. Okay, so all we're doing here is we're saying that don't take the alternative hypothesis. Okay, there's not enough evidence to conclude that people with diabetes who undergo the surgery is less than 72%. The null hypothesis stands, the alternative does not. Right? And that's what we're doing to show this. Right? Let's take a real quick turn of what's going on. Same question. Same question. And same question. Okay. So I'm going to go ahead and leave us there because this video has been long enough. When you're trying to study this, I'm not going to ask you number one. But as you're going through these and you need a lot of help for like the first 2 or 3 of them, okay, that's fine. But as you're going forward, see if you can't do that without any of the help me prompts, show me an example prompts. Okay, make sure you try to do it on your own so that you practice where the buttons are, what you're looking for. There's a lot of P's, like which one did you want? Okay, that's actually going to be kind of rough. All right, so good luck with that. And I'm sure you can do it, dog. It's not the worst thing in the world. All right. So good luck, and I will see you in the next video. Thank you.